All right, so this next video is going to be dealing with the concept of an application of derivatives, and or application of integrals. And the way we're going to do this is actually going to be a two-part video. The first video is going to be a simple unit analysis concept. If we can understand our units, and if we can read a question and be able to figure out what units we want, this becomes really easy to determine whether I want to find an integral or a derivative. In fact, I'm going to tell you that in general, any of you going into engineering or science or anything of that nature, if you can figure out, if you can figure out your units, the math falls out of the problem. It just naturally appears. Now we can do this a little pretty easy. If we look at the first question here, we'll see that I know f prime is feet per second, which if we remember as a velocity, if I take the derivative of that, becomes feet per second squared. Now we haven't talked about this yet, but an interesting thing is that derivatives, of course, are going to add primes. The second derivative is f double prime, third, f triple prime, fourth derivative, fifth derivative, sixth derivative. But we can actually move back up as well. And while we haven't formalized this yet, it's coming up soon when we get back, the derivative and integral wind up being inverses of one another. Now this makes to be an interesting thing. So that means that I can actually get rid of a prime by taking an integral and going back up. So if I wanted to go from f prime to f, I would simply take an integral. And what I would do is I would multiply whatever the unit is inside my dependent variable. So in this case, I would take feet per second, and since this is a t variable, seconds is my independent variable, I would do feet per second times seconds, and I would just get feet. Now this goes for any of these problems that you see below. For instance, if I look at the second question here, g prime of t is pounds per hour. So if I take the derivative, I would take this hours variable and I would divide by another hours to get pounds per hour squared. If I moved up in that, I would lose the pounds per hour. We would integrate the g prime to get g, and we would say that this is simply pounds. Now what I'll do is I'll give you a moment to pause the video and see if you can figure out the rest of the questions. At this point in time, you should have already paused the video. If not, then you're just waiting for me to do the math. That's cool. And what we're going to do is we're going to look at each one of these, and I'm hoping that most of these were pretty good. Most of them. If I took a look at number 3, dollars per week, the derivative of that, we would just add an extra week to the denominator, call that dollars per week squared. If we integrate it up, we would just find out that that would be dollars. We look at 4, I gave you the double prime, just seeing if I could mess with you. If we integrate that once, we would get tons per hour. And if we did it one more time, we would just get tons. Number 5 is feet per second, was p of x. If we took the derivative, we would get feet per second squared. And if we integrate, we would have gotten just feet. And I'm going to come back up through 10 because I know that number 6 is the one you're waiting for. So on number 10, if we take the derivative, that's dollars per feet squared. It's the rate of change of the dollars per feet. P of x is the dollars. We could have feet per second and just feet. Here, that's kind of weird, feet per second as opposed to, or feet per second. I apologize, my brain is getting so tired. Feet per second makes perfect sense. It's the second per feet that gets really interesting. 18. We started at inches per day. This one gets to be an interesting one because we have inches per day. If we took a derivative of that, we'd get inches per day squared. And if we actually take the second derivative, we actually wind up with inches per day cubed. Sometimes our unit is not going to make much. In fact, inches per day squared is a strange unit. Inches per day cubed is just really weird. Just like number 7. Now be careful with this. This is going to be feet cubed per minute squared. What I want to point out is feet cubed is an actual unit for something we know. That feet cubed is a volume, so we're okay with that. So this becomes feet cubed by itself, so we'd have a volume function. And then there was this lovely question where hopefully you recognized I needed to move up. So if I move up once, this is going to be dollars per people times people. You should have gotten dollars. That means the unit of the problem above is dollars times people. That's right, folks. We have the dollars times people. And when we did average value, that was something that you saw. When we took that integral, and I'm specifically thinking of the question where we were doing the bathtub temperature, we wound up with degrees Fahrenheit times minutes. And what is a degree Fahrenheit minute? I don't know. That's a weird unit. But when I calculate out the average value, we wound up dividing by minutes again and taking us back to where we want. So you might get a situation where I might have dollars here, and I might integrate it with respect to the number of people, get a weird unit, and then divide amongst the people to find an average value. So there are ways that our units will get messed up only to be reset because of what we're trying to find. Now on the back of the sheet, this is the part where we get to deal with how on earth do we use this in a problem situation. So I tell you that I got some situation here. C of T represents the cost of specialized lumber in dollars per foot. So I am telling you right here that C of T is dollars per foot. And we read through the question. There's a whole bunch of math that goes into it. It might be this massive word problem, but at the very end, I want to find the total cost of the lumber purchased. So I have to ask myself, what do I want to do? I want to go from dollars per foot, and I want to be able to get to just the dollars. I'm doing a unit analysis. At this point, I need to ask myself, did I integrate or did I take a derivative? And because I got rid of the feet I'm multiplying a unit in, I can see that I integrated. Therefore, we would take the integral from a to b of C of t dt to get a final answer. Now, not every question is going to be quite as obvious as that. Question 4 would be the next one I would say is the easiest. We'll get to that one in just a moment. Questions 2 and 3, I would argue, are probably some of the trickier ones. So let's take a look at 2, and then I will leave you to try 3, 4, and 5. And then I will let you give you a pause moment. So question 2 says that L prime of T represents the rate of the water pouring out of the faucet in gallons per minute. So let's write that. L prime of T, and that is definitely going to be gallons per minute. And the question asks, is the rate that the water is pouring out of the faucet increasing or decreasing? These are change words. I want to know when the rate is increasing. So the rate is increasing when the rate of the rate is positive. That's how we're going to know. I'm not allowed to graph this. So I need to find the rate of the rate. Now notice this time I'm not using a unit analysis. That wouldn't have worked. I have to conceptually understand how the word is questioned to do that. So I need to find the rate of the rate. Well, I'm already dealing with L prime, which is a rate. Ergo, I need to find the rate of L prime, which would be L double prime. I'll give you a moment. I'm going to give you a moment to pause the video here and try out 3, 4, and 5. And let's see how you do. All right, hopefully you had enough time to pause the video and get started up. Let's take a look and see how we did. We'll save number 3 for last. Let's deal with the easier ones first. Question number 4 was simply x is the position, find the acceleration. This should be of no difficulty to you. You should know that if x is position, then x prime is velocity and x double prime is acceleration. That is a relationship that you must know like the back of your hand. That is something that you have to have. So that one I'm not going to spend a huge amount of time on. Number 5, P prime of T is the rate in degrees Fahrenheit per minute that the temperature of freshly baked pie is changing. what is the temperature of the pie? So in this question, we got to find the temperature of the pie. What do I know? I know that P prime of T is degrees Fahrenheit per minute. So if I take the derivative of P prime of T, that would take me to degrees Fahrenheit per minute squared. So P double prime makes no sense. And I probably don't want P prime because that's going to keep me in the same exact spot, degrees Fahrenheit per minute. Not very useful there. If I integrate this once and take it to P of T, that would multiply by minutes. So P of T would take me to degrees Fahrenheit. That would be the temperature of the pie. That's a temperature, degrees Fahrenheit. So my answer is this. By the way, if I would have said the integral from A to B of P of T, then that would have given me degrees Fahrenheit times minutes. So that's kind of an interesting take. And then we'll come to number 3, which is the doozy question. We've got E of T that represents the rate of people entering the carnival. And that's measured in L of T, which is representing the people going out. So both E and L are measured in the hundreds of people per hour. So I noticed, I'm looking at is the amount of people of the park increasing or decreasing? So what I want to do first, I want to realize these are all E of T minus L of T. So E of T minus L of T. And these are both measured in people, hundreds of people per hour, which tells me something. E of T and L of T are both rates. If I want to know the amount of people in the park increasing, I'd like to find the rate of people in the park is plus or minus. Remember, increasing or decreasing, I need to basically kind of think of myself, okay, what do I need to find to be positive or negative? So I need to find out when the rate of people in the park. So rate of people in the park is the people per something. Well, people per hour. The answer to this question is not the derivative. Because if I take the derivative of E of T and L of T, I would get people per hour squared, which is not a rate, it is a rate of a rate. Obviously, it can't be double prime. The answer is actually E of T minus L of T. If we would have integrated this, then we would have just gotten people. And that's the type of thing that we want to look at as we go through here. So this was the end of the first part, which is unit analysis, and we will use this as a tool on occasion to be able to help us through the next section, which is going to be applications of of definite integrals. So hopefully that was helpful, and I look forward to seeing you after break.